In this video, I am going to fit a quasi-Poisson regression model, check for over-dispersion, and explain how this model indicates that over-dispersion is present. First, we will import the libraries. We will import statsmodels.api as sm. We will import pandas as pd, and we will import numpy as np. Then we will read the CSV file and we check the data types of the columns, and we can see that the three columns are of int type and the two columns are of float 64, and the Pashtun is with the values 0 and 1. We will see in the next step. So on printing the levels of the Pashtun, we see that the levels are 0 and 1. So we will change the data type to categorical. So this is how we do that. pd.categorical bracket df square bracket Pashtun, comma, categories equal levels, ordered equal false. So printing the data types, we see that the data type of Pashtun is changed to category. Then we create an array of independent variables, adding a constant column. So underscore and then x equal sm dot add underscore constant bracket df. We'll put the double square bracket because we want to create the data frame over here. So calories, Pashtun, and troops, and comma prepend equal true. So printing the head of it, we see that there are four columns: constant, calories, Pashtun, troops, and the names of the rows are the country names. Then we will create the quasi-Poisson family and fit the model. So this is how we do that. MLE equal SM dot capital G, capital L, capital M, bracket DF, square bracket incidence, comma, underscore X, that is the independent variables, offset equal NP dot log, bracket DF, square bracket pop, comma, family equal SM dot families dot portion, open and close bracket. So open and close bracket, by keeping it empty, the model uses log. Then dot fit to fit the model. So it is generalized linear model. And then printing the summary of the model, we have mle.summary, open and close bracket. We see that generalized linear model is created, and then we see the number of observations 34, dependent variable is incident, and we see link function is log, model family is portion, and Pearson chi-square is 1.16 uh, times 10 to power 3. Deviance is 819.54. Number of iterations is 6. Pseudo R square is 1. Then we will look at the coefficient of constant is minus 4.0973. Calories is 0.0078. Pashtun is 1.9784. Troops is minus 7.204. Exponent minus 5. Looking at the p-value, the p-values are quite close to 0. So all of these four variables are very important. So next we calculate the dispersion, because this summary doesn't give the dispersion. So for checking for over dispersion, we need to calculate dispersion. So underscore dp equal np dot round. We want to round it to 0 decimal places. And bracket mle, which is the fitted model, dot Pearson underscore chi-square. So we have Pearson underscore chi-square is 1.16 times 10 to power 3 and divided by the model dot df underscore recede. So df underscore recede, is it printed over here? Doesn't look like it is printed. And we want this to be rounded to 8 decimal places. That's why we put comma 8. So print dispersion, bracket, curly brackets, label it as dispersion, colons, underscore dp. So we have 38.7206509. The quasipoisson model a has an estimated dispersion parameter of over 38. This is a clear indication of over-dispersion since we would expect this value to be approximately 1 if the Poisson distribution was an adequate approximation of the true distribution of the response.